top of water? Or sailing at high speeds on a solid sheet of water? Have you ever thought about cruising on top of water? Or stretching water? Or seeing water vanish into thin air? Or cutting water? All these things are possible, and all depend on the phases of water. During the next few minutes, we are going to discuss some of the characteristics of water, as well as other materials, and look at why a single substance like water exists in so many different forms. We will also explore the 4 states of matter: solid, liquid, gas, and plasma. Water can exist as a liquid or as a solid in the form of ice. Solids have 2 important characteristics. Solids, like this ball, have a definite shape. Second, solids have a definite volume. In other words, they take up a definite amount of space. Matter, like this brick, is made of tiny particles. The particles move or vibrate slowly. This is how a solid maintains its well-defined shape. In solids, the particles are packed tightly together to create a definite shape. Most solids are made of particles that have a definite regular pattern called a crystal. Snowflakes are a solid made of crystals of water. This is a single 6-sided snowflake. No 2 snowflake crystals are exactly the same. Liquids, like the water rushing in a stream, have no definite shape. Liquids, such as this fruit juice, take on the shape of their container. And liquids, like milk, spread flat across a surface when they are spilled. While liquids do not have a definite shape, they do have a definite volume that can be measured with flasks or graduated cylinders. No matter how the shape of the container changes, this liquid still has 1 liter of volume. The particles in water are freer in liquids and move around more than in a solid. Some liquids have greater resistance to flow than others. This is called viscosity. Maple syrup has a high viscosity and flows very slowly. Maple syrup is derived from sap that comes from maple trees. The sap drips out of small holes placed in the tree. The sap has a low viscosity and drips into buckets like these. Inside small buildings like this one, the sap is boiled for long periods of time. Eventually, the sap turns into a syrup that is sweet and has a high viscosity. It is easy to see the elastic nature of syrup, but water also demonstrates a certain degree of elasticity, a property that implies stretchiness, as seen here. Water can also be a gas, as seen here in the form of steam. Gas is another phase of matter. Gases do not have a definite shape or a definite volume. Quite often, you cannot see gases in the air. However, a vapor can sometimes be seen coming off of water, as in this hot cup of tea, or as other gases seen here rushing out of this valve. And sometimes, even though gas cannot be seen, it can have an odor, as with the case of this natural gas on this stove. Because gases do not have a definite shape or volume, they can be compressed, or they can expand. Gas can be pumped to fill a small volume, as is the case with this balloon, or gas can spread out to fill a large volume, like the water vapor gas filling the air. The fast-moving gas particles in this hot air balloon are more scattered than those in solids or liquids. All of this particle motion causes gases to expand, creating outward pressure. This machine is a gas compressor that squeezes gas into a small volume. The gas is put under such great pressure that it can be used to hammer nails into this piece of wood with tremendous force and speed. This balloon is filled with gas that is pressing against the walls of the balloon. When you squeeze the balloon, it gets harder and pushes back against your hand. By pushing on the balloon, the volume decreases, but the pressure increases. This relationship between volume and pressure is called Boyle's law. Boyle's law states that a volume varies inversely with pressure. Another example of Boyle's law is demonstrated with this canister and this antacid pill. When placed in the canister with a small amount of water, the pill reacts with the water, producing a great deal of gas. The pressure built up by the gas exceeds the strength of the lid and causes it to blow off. Charles's law also describes the behavior of gases. It states that there is a direct relationship between temperature and volume. Let's see how Charles's law works. This balloon has a circumference of 60 centimeters. The temperature in this freezer is well below freezing. Let's place the balloon in the freezer for a few minutes. What do you think will happen? After being in the freezer for several minutes, we will investigate the change in volume. As you can see, the balloon's circumference decreased to 56 centimeters. This means that volume decreases with a decrease in temperature. Let's see what will happen to the balloon with a circumference of 60 centimeters when it is heated. This oven has a temperature of over 80 degrees centigrade. What do you think will happen to the balloon if we put it in the oven for several minutes? After several minutes in the oven, the balloon is taken out and then measured, where you can see it has a circumference of 66 centimeters. Here, an increase in temperature caused an increase in volume. Plasma is the fourth phase of matter. Plasma is quite rare on Earth, but it is quite common in the universe. Our sun, for example, contains plasma. This close-up of the sun illustrates the movement of plasma. Matter in the plasma phase is extremely high in energy. In stars, like the sun, gas particles break down at temperatures of over 1 million degrees centigrade to form plasma. And believe it or not, plasma exists in common household fluorescent lights. This occurs when an electric current converts mercury to plasma.